Alright, so here we go. I hope the video can hear me. In the background we have some Boards of Canada, which I think is good soldering music. It's nice and calm. I'm going to adjust this a little bit. Alright. Try not to shuffle things around too much as I go. So, the basic idea behind soldering surface mount stuff with a soldering iron is to use plenty of flux. It's basically the most important thing. Flux causes the pads that you're soldering to be cleaned once they're heated, and it causes the solder to want to stick to the metal and nothing else. So in a lot of cases you can fix mistakes with extra flux, and you can solder much smaller parts than you would think just by using a little bit of flux, and we'll show that right off the bat with the processor, which is a pretty fine pitch TQFP package, 32 pin I think. So let's get started. The first step is to add some flux to the pads that we're going to solder. We're going to start with the processor, and I just this pen, you just depress it a little bit to cause the flux to flow. So I just depress that and just run it across all the pads that I'm going to solder. One of the things I like to do is blow on the flux after you put it down. Blow on it a little bit and give it a second to sit. That causes it to get a little bit sticky, which makes it easier to position components. So we take our tweezers and grab our processor here. This is a ATmega 328P, and we're just going to rotate it so that it's in the right orientation. We're looking for pin 1 to line up, and then grab that guy and just drop it basically on the pads where we're going to work on it, and then just use the tip of the tweezers to just line everything up nice and even. I don't have especially steady hands, so this can be a little bit slow for me. Plus, usually I work much closer to the board so I can see better, but the camera is doing that right tonight, so you'll have to bear with me. Oops. Maybe edit some of this out in the final video. So that looks pretty good. I forgot to mention in showing the tools that I'll be using, I also use a jeweler's loop. A little hard to see here. There we go. This was a couple bucks from SparkFun, and it has a little LED on top for lighting it. I use this to inspect some of the really fine stuff. Most of it you don't need it, but it's good for this processor. It looks pretty good. So we start just by soldering. We just want to get one pin down to hold the thing still, and then it's much easier to work with. The way that I do this is after using lots of flux, I put a drop of solder on my soldering tip. Just enough to form a little tiny ball on the end of the tip. See if we can see that there. There's the solder. Then hold down the part as we get started with your tweezers and just touch it to one of the pins. Right where the pin meets the board, just touch the solder to it, and the solder will flow up and around the pin and it'll hold it real nice. So usually this uses very little solder, and I can usually do multiple pins with one ball of solder. So I'm going to go over to the other side, and I'm going to solder one of the other pins to give it a little bit more strength. So now we've got 2 pins soldered, and now the chip is held down nice and solid. And just add a little more solder, and then we just go through and finish up the rest of the pins. Just take the soldering tip and slide it up towards the pin, and solder flows right on. So I'm going to do that about 25 more times. You might hear me blowing on the soldering tip now and then. There's no practical reason for that. I'm just doing it to keep the smoke out of my lungs a little bit. I should really have a fume extractor, but I don't have one. And normally at this point, I've done all, from the way that I'm looking at the board, I've done all the pins on the right side. And normally at this point I would turn the vise around to make it a little easier to work with, but I don't want to screw up my camera setup, so I'm just going to try to do the rest of the pins kind of backwards from the way I normally would here. You can clean your soldering tip as often as you want. I usually just watch the tip, and eventually you start to get some debris from the flux on it and that kind of stuff, and that's when I'll run it through the sponge real quick. So I think we've got all the pins now. I'm going to clean my soldering iron, and then I'm just going to pop the board out of my vise real quick and zoom in with my loupe. I don't do this with all the components, but the processor and a couple of the other ICs have such small pins. You want to take them out and take a good look, and what you're looking for is just make sure you don't have any solder bridges, which is where you have two pins connected to each other. And also you want to make sure that there's enough solder around each pin. And I'll check that out, and if we have any problems I'll go through how to fix those. So it looks like no problems. Usually the one that's the most common is a solder bridge, and they can be a little tricky to fix. What I'll generally do is apply more flux, just basically dump flux on top of the bridge and all around it, and then just kind of fiddle around with the tip of your soldering iron and see if you can pull the solder away from the bridge. If that doesn't work, what always works is just use a little bit of solder wick, which we have here. Here's some solder wick, and what you would do is, I'm going to use my tweezers instead of the tip of my soldering iron, but you take your solder wick, lay it on top of the bridge, and then use your soldering iron to press down on the wick. Just hold it there for a second and you'll start to smell the flux in the wick melt, and that'll suck up a ton of solder and usually clear the bridge. Usually, in fact, it sucks up so much solder that you want to resolder those pins when you're done, because there won't be much solder left on them. So now we'll move on to some of the easier parts. The next one on this side of the board is going to be the crystal. So again, we start with some flux. I keep bumping my head on my light here. I'm going to move it a little. There we go. So a little bit of flux on the crystal pads, and pull the crystal out of our components here. Actually, looks like I forgot to get the crystal out. And the inductor. Get both of those out while I'm here. So take our crystal and drop that on the board. The crystal is not polarized. You can put it in either direction. So pick whatever you like. And we're gonna just set that down and line up the pads. Nothing has to be exact. I like to get them as close as possible, but as long as they're touching and you can flow solder, you've done a good job. So same deal here. Just pick up a little bit of solder on the tip of your iron. Hold down your part and just give it a real brief touch right where the pad meets the part, and you'll see the solder jump right in and fill the gap between the two. It's a lot easier than it looks. And do that to the other side, and that's done. So the last thing that we've got on this side of the board is a bunch of capacitors and resistors. These are all 0805 sized, so they're pretty tiny, but I find they're just as easy to solder as anything else. Do these pretty quick, so I'm just going to flux all the pads. So all these resistors on the bottom, these two capacitors, these two caps, and these two resistors. Just put plenty of flux on all the pads. I'm going to bring my parts up. At this point I need to reference my list, which I have behind the camera here, just to remember what each part is. So we'll start with these three resistors along the bottom. This is R1, R2, and R3, which is a 10K and two 4.7Ks. So we grab the 10K, out of our parts bin here. Not seeing it. I missed that one too. Looks like I forgot to grab that one too. Oh wait, no, here it is. It's just upside down. Some of the caps have a light colored top, and they look, if the resistor is upside down, they look the same. So that's actually the 100K resistor. So we've got resistors labeled 102, 103, and 104. 102 is 1K, 103 is 10K, and 104 is 100K. So 103 is what we want here. We'll bring that up, and we'll grab two 4.7K resistors while we're in the parts bin. So R1 is the 10K. So we just grab that with the tweezers, which can be tricky. I'm just trying to get the numbers on it the right way around, and just drop that on the two pads, and then same thing with the two 4.7K resistors. Just that one, just a tiny bit. Then similar process, we just put a drop of solder on the tip of the soldering iron, hold the part still, and solder one side of it. Doesn't take very long. As soon as you see that solder flow, then you're good to go. You can pretty much pull your iron away and the part will stick. So I'm doing one side of all three of these components right now, just to get them all stuck to the board. And then I'll just grab a little more solder on the other, or on the tip of my iron, and just hit these other sides of all three components. And that looks good. So the next step is the two 8 picofarad capacitors. These are the load capacitors for the crystal. So I'll bring those up. And just want to make sure I don't have a resistor in my hand here. Yep, those are the 8 picofarad ones are the light colored ones. Kind of a gray color. So we'll place those. Oh, I just flicked it out of my tweezers and lost it. Okay, we're gonna have to get a replacement one of those. Luckily, capacitors come in buckets of 1,000. So, just make sure it didn't. It sounded like it went right in the parts bin, but I don't see it. So, let's grab a new one of those. Alright, try not to do that too often. So we'll take that cap and set it right on the pads. At this point the flux is for these, it's been on here a while, it's actually getting pretty sticky. It makes it really easy to position things, they don't slide all around on you. So, same as before, I won't narrate every single part. Once you get into these 0805 parts, they're all the same and it's pretty easy. Those are good. So now we'll do the next set of 2 capacitors, which is C3 and C11. C3 and C11 are both 100 nanofarad. Those are the only 0805 caps that we have in the parts bucket, except for the 2 8 picofarads we just did, and the 100 nanofarad 100 volt cap C5, which is much larger. It's really easy to identify. So grab a couple of these and put them down where they belong. These 100 nanofarad capacitors are power supply filter and bypass caps. And they're all over the board. I think there's 7 or 8 of them on the board. They just keep noise out of the ICs, and they keep the ICs from creating power spikes on the power bus when they draw extra power. I moved that part a tiny bit as I was starting to touch it, so I had to reposition it. I don't know if you can see it in the video very well, but I kind of rest my pinky on the vise while I'm soldering to steady my hands. I don't know if I drink too much caffeine or if I'm just old, but my hands shake a little bit. That's done. And last 2 on this side are R4 and R5, the resistors. We have a 100K and a 1K. These form the voltage divider that lets us get feedback from the high voltage power supply. So bring those up out of the bucket. 104 and 102. R4 is the 100K, which is the resistor marked 104. and R5 is the 1K, which is marked 102. Oh, looks like I made my first mistake. This resistor moved just as I was starting to solder it. So what I'm going to do is just put some pressure behind it, melt the solder, and just lift it off. So now this is good because it shows how to fix these kind of errors. The pad has a little ball of solder on it, which will cause the part not to sit flat if we try to solder it on there. This is real easy to fix. Just reposition the part right on top of the little dome of solder, and then instead of adding solder, make sure your soldering tip's nice and clean. Hold the part still and touch that little dome of solder, and it'll just remelt and run right up the side of the chip. So it's no problem. Alright, there we go. I'm going to add a little more solder to the other side of that one that I messed up. There we go. So now we're done this side of the board. It's a good time to pop the board out and do an inspection with your loupe. Make sure everything looks good, plenty of solder, no bridges, and I'll do that now. Or I'll just throw my loupe on the ground. Alright, all of our connections look good. So it's time to flip to the other side. So this side is noticeably more complex. Lots of big parts on this side. We have, point out some sections. We have the high voltage power supply, which is most of this area up here. We have our low voltage supply here. This is our VFD tube driver chip, our real-time clock chip, power connector, pin headers for programming and expansion, rotary encoder, battery holder, and then there's a couple little 0805 components scattered through. This side should go pretty quick. So I'd say the hardest parts to solder on this is the inductor here and this large capacitor here. So what I like to do is start with those two to get them out of the way, because they're such large components that it's difficult to get your iron around them, or around other components to get into them as you go along. So I'm going to start with the inductor. Same deal, plenty of flux on the inductor pads. And then I'm also going to solder C6 at this time and C7, so I'm going to go ahead and flux the pads there. If you look at the bottom of the inductor, you can see, see if we can show it here, there's some metal pads that go all the way to the surface of the board. And those are the ones that you want to line up with the pads on the board, and configuration should be the same. So what I just do is just set it on there, and then the 224C should be to your right as you're looking at it. In the video I think it's to your left. So that looks like it's lined up pretty well, and these parts use much larger pads than the 0805s, so put a pretty good dollop of solder on your tip, get a good ball on there. And then you'll have to turn the iron just a little bit as you touch it, because the pad is kind of hidden under the part itself. So we did this side, and we'll do the other side while we're here. I can't really see because of the camera, so maybe I can use the camera to do it actually. That looked pretty good. Check that out at the end. The next one is the 22 microfarad 63 volt capacitor C6, which is the largest cap in the bucket here. I'll set that there. And these go on just like the board indicates. The plastic base is kind of angled at one side, so you just put that on the same way as the silk screen shows. Flux on this one is starting to get sticky as well. A little harder to position things. Alright, that's good. That one's done. And then C7 is good to get out of the way as well, which is a little 47 microfarad 25 volt capacitor. And slide that one into position. Okay. One's done. Now the next difficult ones are the MOSFET and the voltage regulator. These are only difficult because they have a large metal tab on the back. I kind of cheat on these. They should be soldered. The whole size of that tab should actually be soldered to the board, but that requires heat from under the board, which we can't do with a soldering iron. So I solder along the back of the tab, and I float the solder pretty well to get a lot around it, and I'll show that technique now. So we're going to hit these big pads here with flux. The two little pads sticking off. Big pads there, and two little pads there. So the first one we'll do is the MOSFET. This is marked IRL R110. It and the voltage regulator look the same, so make sure you check the markings. Turn that. So you want to line up the three pads, the two very small ones for the legs and the one large one for the tab. And then you have some leeway on where this thing goes, so you want to move it so that the feet cover more of the pads than the tab does. You want to leave a little bit of the tab, the pad for the tab showing, which you can see right here, and that's where we're going to flow that big bulk of solder to hold the whole thing down. So what I like to do is solder one of the feet first to hold the whole thing still. That gets that. It's a little easier to deal with after that. And then we have the big tab. I actually use larger solder for this. I have some of this old school Radio Shack solder. It's a little thicker, and it's rosin core. and we're going to use so much solder on this tab that it's just handy to have the thicker solder. You can do it with thin solder, but it doesn't really make too much difference. The trick here is this tab is going to act like a heat sink for your soldering iron, so you actually have to apply the soldering iron for a decent amount of time to actually heat it up. And you can see once you've done your job right, because the color or the texture of the solder will change and it'll start to flow up the side of the tab. And at this point you know that the solder is actually attaching to the metal and not just sitting around it. So hopefully the video will show that. And like I said, you have to hold it on there a second to get things going. There we go. So I just flow it right back and forth there. And you can kind of see the solder liquefy and start to flow up the side of the tab, which at that point, good to go. And now the voltage regulator. And now that I'm looking at the board, it may actually be easier to solder this regulator before this capacitor, before the large capacitor. It might be a little easier to get in behind it, so that's an option. So just like the last one, solder a leg first. If I go back and touch up a spot that I already soldered, it's just because I think maybe I didn't get enough solder on it. So I'm going to turn the vise just a little tiny bit here. And then same deal. Yeah, I think you definitely want to solder this before that capacitor. It's a little tricky to get down in there next to it. Looks pretty good. So the next thing we'll do is our diode D3, flux for that, and I'm going to go ahead and flux the pad for R7 and C5 and C9 while we're at it. Those are all kind of in the same area. Diode is up next. The diode is marked with a white line on the device itself. That white line should go in the direction of the arrow that's on the silk screen. And you can kind of treat this the same way you do an 0805. It's just a big version of that. Just get it lined up, hit one side, and then hit the other. Alright, R7 is getting kind of buried at this point, so we're going to do that next. R7 is a 4.7K. And it goes right down here between the MOSFET and the voltage regulator. If you find that you have to bump another component with the side of your soldering iron while you're working, you don't have to worry too much. It's pretty tough to damage these components. they're made for going into ovens and using reflow temperatures, which can be pretty high. So if you have to expose the side of the device to the side of your soldering iron for a couple seconds, it's not going to cause any problems. C5 is next. That's our 100 volt, 100 nanofarad, which is the only really unique capacitor that we have. We grab that. You can tell the difference. It's about twice the thickness of the rest of the capacitors. It's almost a perfect square in profile. So that is C5. Went on just a little crooked, so see if I can give it a nudge without screwing it up. Yeah. I actually popped it off of the pad, so what I'm going to do is just put a little bit of solder on the pad itself. Then I'm going to treat this like the other error that I made. Just set the part right on that domed pad. Hold it down. And just melt that side of there. It's still a little crooked, but I'm going to go with it. It's clear that the device is resting on the pads. Nothing's shorting, so I'm just going to leave it the way it is. Actually, I'm not. Maybe I'll edit that part out. I'm going to go ahead and try to fix it. It's pretty crooked. So I just removed it completely just by adding a little heat and hitting it with the tweezers. So I think what I'll do here, got a little bit of extra solder on the device itself. And melt that off. Gonna add a little bit more flux to this set of pads so they get cleaned up. And I'm going to put a little bit more solder on the pad itself. Get a nice dome. This is actually an alternate method of soldering small surface mount stuff. You can actually dome one pad and then apply the device, but generally I find it's a little faster to hold the part as you solder it instead of putting the solder down first. I cannot get this chip to stay put. There we go. And the other side is soldered. So the last power supply component is C9, which is another 47 microfarad 25 volt cap. And we'll slide that into position. And that's good. So at this point, we're getting into the part where we start soldering some of the larger chips, which also happen to be the expensive components on the board. So what I'd like to do is pull the board out now, do a visual inspection, make sure we haven't made any mistakes that are not correctable, and then we'll continue. One option is to spill all your parts all over the table. That's not recommended.